research papers in national conferences. Mr. P. Arjunraj is a resource person for many different workshops, training programs, seminars, and guest lectures in different companies, R&D institutions, academic institutions related to value engineering, operational research, total quality management, manufacturing technology, emission control technology, electric vehicle technologies, quality automotive engines, automotive transmission, etc. He is also the motivational speaker to the students and faculties in various engineering colleges and different business schools. Mr. P. Arjunraj has worked in BEML, Bharat Earthmovers Limited, Government of India Enterprises, in Service and Validation Department. He has also worked in Mahindra and Mahindra Limited in Engine R&D Division. He has worked in PSA Group Motors and Powertrain Research Development Department. He also received few awards. I am going to list only few awards. He has received many awards and many recognitions. Due to time constraint, I am listing very few. He is a recipient of Gold Medal Award 2015 and 2019 by Indian Value Engineering Society for the outstanding contribution related to value analysis and value engineering in industry. He was awarded Miles Value Foundation Paper of the Year 2016 by Society of American Value Engineering. He is the youngest Indian to become Certified Value Specialist, highest level of certification in the field of value engineering certified by SAVE International USA in June 2018. Youngest Indian to get the license during the March 2020 from SAVE International USA to conduct value engineering workshop and certification in any companies and any institutions. He is also the management committee member in Society of Automotive Engineers, SAE India, Southern Section, Hosur Division from December 2018 to December 2019. So it is a very honor to have such an eminent personality with us. He is going to elaborately discuss about evaluation, simulation, and modeling of electric vehicles. So I take the opportunity once again to welcome Mr. P. Arjunraj on behalf of the Management Department of Mechanical Engineering and on my own behalf. Welcome you, sir. The session is yours.
Yeah, thank you, Professor Dr. P.K. Devan, for your kind introduction. Yeah. Now I would like to call upon our eminent speaker, Mr. P. Arjunraj, to disclose his presentation on evolution, simulation, and modeling of electric vehicle. The session is yours, sir. Please take it on.
Good morning to all. Thank you for the opportunity. So today, so I'm going to divide my seminar into two parts, part one and part two. So today we will see the part one, and then tomorrow we'll be seeing the part two. Okay. So part one is basically about the basics of the e-mobility. And then in part two, I will be covering the performance and then the evaluation, simulation, and modeling of electric vehicle. Okay. So my presentation is divided into two parts, as I said. So part one will be covered today, and part two will be covered tomorrow. So in part one, I will be dealing with electric vehicle chronology, basic concepts and terminologies of electric vehicle, and I'm going to give a case study about the electric bus technology of Ashok Leyland. And I'm also going to give the case study of a vehicle called Ether vehicle. It is manufactured by Ether company, Ether Energy in India. It is located in Bangalore. And tomorrow I will be giving one more case study on the topic called TVS Vigo electric vehicle. And then some of the electric vehicles which are already developed in market, and then their performance will be seen tomorrow. And importance, what is the importance of this electric vehicle performance? And we will see the evaluation of electric vehicle, and then we will study some case study related to the electric vehicle and also the modeling and simulation. Instead of directly going to the evaluation, modeling, and simulation of electric vehicle, let me complete the basics. Then we will go with the modeling and simulation. Hope this will be good. So we'll see the electric vehicle chronology. So this electric vehicle is not a new concept again. So professors, faculties, students, industry persons, researchers, for everyone, it's not a new concept. Okay, but people think that this is a new concept, and in the year 2020 and beyond 2020, electric vehicle and hybrid will be the number one, and it's not the other way. Like the conventional vehicle will be out of the scope. Again, this electric vehicle or electric car concept or electric technology, okay, it's started way back in the year 1835, where the Americans they developed the electric carriage. Okay, 1835 itself they developed. Okay, and again we are in 2020. You can see almost um, 185 years now ahead, and people still says that it's again the booming technology. Okay, this electric technology or electric uh, concept had evolved long back. Okay, and again, it's like a small baby. It's inside uh, the, the incubation of mother inside her, and then once it comes out, it needs some lot of stages. Okay, it's not that the born baby is going to be a 70 years old immediately. It needs lot of stages. Okay, and it slowly grows. Okay, similarly the electric vehicle technology is also, though it's born in the year or it started in the way back in the year 1835, almost 185 years ahead now. So it has slowly evolved. Okay, a lot of a lot of development has happened with respect to the hybrid technology as well, which involves not only the electric but also electric along with the conventional engines like diesel and petrol. And there is a huge leap had taken beyond 1990. Okay, there is a big economic development that happened after 1990, which paved a way for the hydrogen development, fuel cells development, and also for the development related to electric plus hybrid. Moreover, people prefer to go with hybrid because in those days, especially in the year 1990s, people were unaware of the technologies related to battery or the charging system or infrastructure system. Now we are in 2020, still we are facing the problem, but you can imagine 30 years back how it was, or how it should have been. Okay, so but there are a lot of vehicle, even the Toyota Prius, they launched a hybrid version in 1997 in Japan, and followed by beyond 2000. Okay, so 1990 to 2000 is one stage, and 2000 to 2002 is 2010 is the second stage, and 2010 to 2020 is the third stage. Okay, so again, it's like a child having different three stages of their life. So the first stage is started in the year 1990, where the Toyota Prius and some of the vehicle has been launched across the globe, especially Toyota. They played a vital role, and beyond 2000. Okay, again the hydrogen vehicle are also grown up. So even though the Toyota launched the hydrogen fuel cells in the year 1995, the evolvement has happened not only in Japan but also in USA, there 2002, and the Tesla. Okay, even though they started slightly late, they launched the very good version of the vehicle in the year 2010, followed by now the Tesla is also ruling the market of e-mobility. You can see you can see there is a huge development that happened in hybrid vehicle. Okay, so as I said, hybrid is not only with respect to electric technology. Hybrid is nothing but the combination of electric plus the conventional engines, which may be the diesel or a. So in the year 2007, you can see there are almost 1 million hybrid vehicles which are being sold worldwide. And in the year 2009, okay, just 2 years gap, the number of vehicle of hybrid which has been sold worldwide had been doubled to 2 lakh vehicle. And again, you see, in the year 2011, almost 1 lakh vehicle had been added. So which means between 2007 to 11, almost 3 times the number of vehicle of hybrid had tripled, which means tripled, not doubled. Okay. So every 4 years, which means every 4 years, the market is booming almost 200% with respect to the hybrid. Okay. Now we are in 2020, pre-corona stage and post-corona stage. Okay. In pre-corona stage, okay, even there are a lot of hybrid vehicles which are there in the market, launched by many companies, Nissan, Toyota. There are a lot of vehicles. Okay. Hyundai, all the players, they played a vital role before corona stage. Okay. Now we are in corona stage, and post corona again, there will be a lot of new vehicles, new versions will be coming with respect to hybrid and also electric. Okay. And now electric is also going to have a big peak, because as per the government norms, in the year 2023 in India, no vehicle of e-rickshaw and e-auto, basically a three-wheeler segment, would have neither a conventional form of energy, which means in the year 2023, all vehicle, especially a three-wheeler, e-rickshaw and e-auto, should have the electric concept in it. Okay, which means it will be completely banned. Okay, so conventional vehicle will be completely banned. Conventional concept will be completely banned in the year 2023 for e-rickshaw and e-auto. There is a good scope post corona as well. And again, in the year 2030, so all the two-wheelers which is running in India should must be converted to electric, which means beyond 2030, all the two-wheeler manufacturer will also go with electric two-wheeler. Okay. And now even Mahindra, they launched Mahindra tractor with the electric concept. And again, you might also be knowing the electric version of Mahindra e-Verito. So and again, Mahindra is also the leader with respect to the E2O Mahindra Reva, which you can find it more in Bangalore and also some in Chennai as well. So as far as chronology is concerned, so the initial stage of electric vehicle concept, the mid stage of electric vehicle concept, and what is the stage today and what will be the stage tomorrow. These are the things you need to analyze. Okay. Being a Hyundai and Toyota, which are the leaders across globe, in India, especially in India, we need to see what are the development that happened. Okay? So in India, the major development has started beyond 2000. So though the world had started the first development in the year 1990s, India started in the year 2001. Mahindra is the first company, Mahindra Reva is the first company in India to get launched, um, and it proved a very latest one with respect to the e-mobility, followed by Mahindra E2O, which they launched in the year 2013. And BMW is again I8 launched in the year 2015. So you can see you can divide the economy into two category. Okay, the medium level income people and then the high income people. Okay, low income people basically they go with the two wheeler. When you are getting the medium income or when the economy of the person is medium, then they normally go with the car segment basically. So for them, the concept of the Reva or E2 will be good. And if the and even some of them they can go with SUV of the electric or e-mobility concept as well. But when the income is on the higher side, okay, or they can go with BMW i8 which is also on the higher side of this one. And again, as I said, Mahindra E2 has been launched. They launched it year 2016. And E2O is also been taken a new shape called E2O Plus. Okay, Mahindra they launched. When I was in Mahindra, I was also working for the powertrain development of the Verito. And you see, in the year 2016, Volvo also they launched the SUV segment called XC90T8 Excellence. Followed by year 2017, BMW i8. They taken a new shape called BMW i8 Roadster. And for the past 3 years in India, you can see there are three important players. One is Mahindra, Tata, and Hyundai, and of course the fourth player called Nissan as well. Okay, so all these are playing a vital role between the 3 years 2018 to present stage called 2020. Okay, so Mahindra they launched KUV 100 in electric version E version. Okay, so I was working for KUV 100 when I was in Mahindra for a powertrain version, not with respect to E, but the concept had been slightly towards electric vehicle. And Mahindra also launched E2O NXT. Okay, and Tata they launched E-Tiga, Tiago. So basically, it is also having the conventional version. Okay, they call it Tata Tiger and Tata Tiago. And Hyundai they launched Kona Ioniq. And the Nissan Leaf is quite interesting vehicle where they given the battery life of almost 8 years warranty. Okay, and Unity One is also the one of the thing which launched. So you can see the past 3 years. You can see the development which had happened. You have the conventional vehicle, which means you have the vehicle which the low, I mean the medium income people can also buy, and the vehicle which the above average and the excellent income people also can buy. Okay, and of course, even in two-wheeler, there are a lot of development that happened, which I have not highlighted here, especially the Ether, TVS. They were the two, even Hero MotoCorp. There are a lot of players even in two-wheeler. Okay, and coming back to the commercial vehicle, basically buses and some of the passenger cargo and other thing. Okay, especially the Ashok Leyland, they launched Ashok Leyland circuit between 2013 to 2015. They launched, and in Mahindra also they launched the e-Supro version. The Supro is a vehicle which was launched initially with the conventional one. Then they moved towards the e-Supro version, electric version. It's a 0.9 liter diesel engine basically for a conventional one. I was also part of a development when I was in Mahindra for the Supro vehicle. And in the year 2016, Goldstone DOAD, you've also seen this vehicle in some of the places. Basically, some places I have seen in between the Mumbai to Hyderabad uh, NH. You can see I have seen this vehicle. And this is also a quite interesting vehicle. Tata Starbus Ultra Electric. This you would have seen in many places. And Goldstone DOID is also launched the e-bus K6 version in the year between 2018 to 19. And then the HF, they launched the Skyline Pro Electric, and JBM also they launched the JBM Solaris Eco Life. Overall, you can see there is a lot of development is happening across all segment of vehicle, two-wheeler, and even e-auto, e-rickshaw also a lot of development, which I have not highlighted, but you can see almost you can see there is always a positive trend that you can find with respect to the electric vehicle concept. Okay. Now I'm going to compare the three major SUV of the electric vehicle especially in India, which they played a vital role with respect to the sales and also the customer retention and also the customer satisfaction. The three SUV in India, basically electric car of SUV in India, Tata Nexon, electric vehicle concept, MG ZS model, and Hyundai Kona. These three is the benchmark for the SUV category in India. The price range between 14 lakhs to 24 lakh. Tata Nexon starts with 14 lakh onwards, and MG ZS starts with 23 lakh 58,000, and Hyundai Kona the cost comes around 23 lakh 90,000. We will see some of the interesting the characteristic feature of the Nexon ZS and Kona. You can see basically the design. Okay, the design concept starts with the starting of the design of a vehicle. Basically starts with what should be the length, what should be the width, what should be the height, what should be the wheelbase, what should be the center CG, what should be the ground clearance, and what should be the wheelbase. Okay, and what should be the overall weight of the vehicle. These are the things that basically it starts with the design concept. Basically, you can see the length basically varying between 3,994 to 4,180 with respect to the SUV category. And with respect to width, there is no difference among the three vehicles, which ranges between 1,800 to 1,811 mm. So normally the length can be higher and the width should be slightly lesser, because especially in the case of the traffic condition, what they feel, if the width is higher, it sometimes it becomes difficult for the driver um, to overcome the traffic condition. Okay, so and with respect to the height point of view, also there is only minute difference among the three vehicles, almost 37 mm, which is quite normal. And you can see the wheelbase also. The wheelbase is more for a Hyundai Kona, and when the wheelbase is higher, now obviously you can see the wheelbase is nothing but the distance between the center of the wheel, one wheel to the other wheel, which means front wheel to the rear wheel. And you see the ground clearance. Okay, the ground clearance is very important. Lower the ground clearance is always better. So it is less for Hyundai Kona. And the other important features apart from the design is the performance. Okay, basically the performance is very important. The performance is always based on with respect to engine. Okay, with respect to the normal engine, the performance is based on engine and transmission. With respect to the electric vehicle concept, the performance is always based on the battery capacity of the vehicle. So when I said battery capacity of the vehicle, as I have compared the three vehicle, so you can see the battery capacity is more for MG ZS model, 44.5 kilowatt hour, which means higher the battery capacity, you will have the corresponding increase with respect to the power. You can see the power in terms of PS, 150 PS, and correspondingly, there is also the other version of a battery capacity for Tata Nexon, which comes 30.4 kilowatt hour, and 39.2 kilowatt hour for Hyundai Kona. Accordingly, you can see there is a change in respect to the power. Higher the battery capacity, you have the higher power. And again, the torque. Okay, the torque is also very important, because higher the torque, basically the torque and speed are related towards the power. Okay, and again, how you are adjusting the torque, how you are maintaining the torque, how you are delivering the torque, that will determine the power of the vehicle. And you see the range. Okay, the range is also very important, because when anything is concerned with respect to electric vehicle concept, for single charge, what will be the range? So the Hyundai Kona, you can go up to 452 kilometers. That's why the cost is also on the higher side. The cost is also on the higher side. And again, you see the torque is also better. The torque is also better. And you see, for a single charge, it can go up to 450 kilometer. Similarly, the MG motor can go up to, ETS model can go up to 340 kilometer, and Tata Nexon can go up to 300 kilometer. So people normally prefer to go with higher range because for a single charge, you can go that type of range. And again, the acceleration is very important. From 0 kilometer to 100 kilometer per hour, what is the time taken? And then normally in race car and all, you can see the acceleration is very much important. In fraction of second or in minimum second, you need to reach a particular speed. Because when the pickup is on the higher side, when the acceleration is higher, and the time taken to reach particular speed is lesser, the speed of the vehicle will be more, especially in racing car. Then it is easy for the particular vehicle to overtake the other vehicle. And this acceleration is also based on the not only with respect to the power and torque of the vehicle, but it also based on the overall weight of the vehicle. The overall weight of the vehicle and other lightweight designs is very much important. So this acceleration is the whole concept. It's not only restricted to the performance alone and also the design alone, but it's also based on design plus performance plus material plus also the overall the design activities, design features like the aerodynamic structure or the aerodynamic resistance, because the vehicle normally have to withstand the aerodynamic force or aerodynamic resistance and also the rolling resistance and also the braking resistance. Okay, so all these three will also have the effect with respect to the pickup of the vehicle as well. So the complete electric vehicle mobility. Okay, so you have the two-wheeler concept, you have the auto e-rickshaw concept, bus concept, commercial vehicle concept, etc. So I'm also working for some of the OEMs. I'm doing some consulting work, basically some two-wheeler company and also for the e-auto and e-rickshaw company. It's a startup in Pune. Um, so I'm doing some of the consulting work for them as well. So we will see some of the case studies with respect to two-wheeler and also the Ashok Leyland bus application as well. So as I said, in part one, we will be covering case study of two-wheeler, Ether, basically Ether energy, and in part two, we will cover the TVS Vigo case study, followed by the simulation as well. And we'll also see how the bus concept are also playing a vital role in India, basically also clear vehicle. So we'll see some of the basic concepts and terminologies which are there in electric vehicle. So we have three versions of the electrification. So basically, electrification, hybridization is very important. Okay. So you have different type of hybridization, which I will show you in the next slide. So first we will see what is called electrification and what are the different type of electrification we have. So basically, currently all the vehicle, majority of the vehicle are with conventional one where you have the engine and transmission, for which the source of energy is fuel. So when I say the pure electric, okay, instead of fuel, you have the battery. Battery is the source of energy. And the engine is replaced by a term called the substitute, okay. So engine is substituted by a motor and generator. So when we are having the regenerative braking for a vehicle, the motor will act as a generator. Of course, we have a transmission as well, where the transmission is much more complicated in the case of conventional vehicle, whereas the transmission is much more simpler in the case of electric vehicle. If you have the single speed gearbox, you can run your vehicle with respect to the electric vehicle concept. Whereas in the case of conventional, you need to have the 6-speed gearbox, and again you need to have a lot of rotating components. You have a lot of mechanical parts as well. But if it is the electric vehicle, the transmission is very simple. You need to have only single speed gearbox, and again, but only problem is when you're designing the heavy duty vehicle, basically the truck kind of thing, or the truck where the Ashok Leyland also they done the E version of it. Apart from bus, basically, if you are carrying the commercial vehicle, like the load carrying capacity is on the higher side, basically you call the truck segment. In such cases, the transmission should be multi-speed gearbox. But with respect to the car segment is concerned, the transmission is much more simpler. Even two-wheeler is also much more simpler. And again, we have one more concept which lies between the conventional. Which does not lie between it. It is a combination of both conventional and electric. Okay, so here you have a motor and engine. So you have to see the importance of this. Because when the vehicle is running in the city condition, okay, where the traffic is more, you can save some fuel. Okay, you don't need to run using the engine. Okay, you can save fuel by the time you can run your vehicle in battery condition. Okay, when the vehicle is running in traffic or in some city driving condition, you can run the vehicle in battery mode or in electric mode. Similarly, when the vehicle is running in the national highway or expressway where there is no traffic, where you can take the vehicle to the maximum speed as much as possible, where the performance is very much important, there you can run your vehicle with the help of the engine, where you are getting the fuel as a source of energy for your engine. Okay, and even if in case if your battery gets discharged, what happens is that when a battery gets discharged, still even in idle condition or in start-stop condition or in city drive condition, you can run the vehicle in the help of the engine mode, and you no need to worry about it. Okay, still you will be in the safer side, or still you can feel comfortable that you can reach the destination where you want to reach. There are a lot of advancement which is happening with respect to the charging aspect. You have static and static charging, inductive charging. So you have a lot of charging. Nowadays, they are also doing the battery swapping. Okay, you need to swap the battery, and you don't need to wait for uh, for the charging to take place. There are a lot of swapping is also happening. But the problem is, while you are swapping the battery, you need to have the standardized size and shape. Okay, if the size and shape does not match to your battery requirement, then again it will be a problem, and you cannot swap the battery. And of course, now you have a lot of technologies with respect to fast charging. Basically, with many of the OEMs also they are doing this. If not in India, at least in Europe countries and US, they are doing this. Where they will also charge the vehicle when the vehicle is also in a moving condition. Okay, so we have seen the electrification concept. Now the next is the hybridization. Okay, it is like we have two eyes, two legs, two eyes, two kidneys. Like this, we have two important verticals: electrification and hybridization. Okay, so when I say hybridization, I'm going to divide the hybridization into four concepts or four verticals. The first vertical is micro hybrid, second vertical is mild hybrid, third vertical is full hybrid, and the last vertical is plug-in hybrid. And I'm saying in the micro hybrid version, which is the first vertical of hybridization, it normally has only the start-stop application in it. Okay, which means this concept is mostly used when the vehicle is running in the traffic condition. Where when I was in Mahindra, I was using this micro hybrid version. I was also part of the development activity. And the mild hybrid is also the concept which involves the start-stop application along with the regenerative braking, and it will operate above 60 volts. And this mild hybrid is also uses a starter motor to assist the combustion engine. So I was doing the development testing, basically even the design activity, design development testing of a micro hybrid, mild hybrid for the Scorpio version in Mahindra. And coming back to the full hybrid, okay, what is the difference between mild hybrid and full hybrid? So in the case of full hybrid, you have the electric motor which can drive all the time. here you don't have the electric drive, but you have the starter motor kind of thing. That's the internal combustion engine. And the last one is the plug-in hybrid concept. Okay, so again, this is playing a vital role, where you also have, in addition to full hybrid, you also have the concept of recharging the battery from the outlet wall for a full extended electric range. So you have the we call PHEV, plug-in hybrid electric vehicle. You have PHEV 40, PHEV 60. So what is the meaning of PHEV 40? Which means PHEV 40 stands for 40 miles, PHEV 60 stands for 60 miles, which means in a single charge, with the help of the battery, which is being used for extending the electric range, as I said, for a single charge, you can use the vehicle for 40 miles coverage of range and 60 miles coverage of range for PHEV 60 and 40 miles coverage of for PHEV 40. And you can see some of the vehicle respect to micro, mild, full, and plug-in hybrid. So my previous organization was PSA Motor, basically Peugeot Citroën model. They launched this Citroën C3 in Europe, it is a French-based car company. I was also working powertrain in R&D. But this electric, the hybridization concept there in the French version, where in most of the Europe countries they use Citroen C3 model. And of course, for a mild hybrid, you can see the Honda Insight vehicle, and the Toyota Prius for a full hybrid, and Chevy World for a plug-in hybrid. So you can see when the hybridization concept is moving from vertical 1 to vertical 2 and to vertical 3 to vertical 4, there is always a efficiency improvement. So you can see there is always a efficiency improvement between one vertical to the last vertical. Okay, so as I said, you have three type of activity. One is with respect to the pure conventional vehicle, second one with respect to the pure electric vehicle, and third one with respect to hybrid vehicle. So we'll see how the energy loss or energy comparison between the three version along with the different driving range. When the vehicle is running in city, when the vehicle is running in highway, how will the energy loss will take place or energy conversion will take place? That we will see. So as I said, the fuel is the source of input for an engine, where I'm considering 100% efficiency as for the fuel. Okay, basically it is coming out of the fuel tank. When the fuel is coming to the engine, what happens is there is always 76% loss in respect to engine. Okay, see, as I said, this energy concept. Okay, basically law of conservation of energy. You might have studied in physics law of conservation of energy, which says that energy can neither be created nor be destroyed, but it can be transformed from one form of energy to another form of energy. So here, the chemical energy is the input thing for a IC engine. So here, the chemical energy is always transferred, is converted to the thermal energy because you are going to get heat. Okay. After the thermal energy, what you are going to get is some mechanical work, which is nothing but mechanical energy. Okay. And finally, you are going to get the work. So you know, a lot of energy which is the transformation is taking place because of the engine, and especially the thermal energy, basically the heat energy. Okay, when the heat energy is converting to the mechanical work, when the thermal energy is going to get converted to mechanical energy, there is always a lot of losses will happen. Okay, there are a lot of losses like blow down loss, blow by loss, heat loss, time loss, pumping loss, etc. So we'll see what is called time loss. Okay, when we are injecting the fuel, okay, the combustion will not take immediately. It takes some minimum nanosecond time to take the combustion. Okay, that loss is called time loss. What is called heat loss? When the heat is getting uh, liberated from the piston, and it takes some time for the heat to reach the cylinder wall. That is called heat loss. And the third loss is the blow-by loss. So you have different concepts like piston pin, piston ring. When there is always a leakage will happen beyond the piston ring. That is called a blow-by loss. So what is called blow-down loss? So you have intake stroke, exhaust stroke, power stroke, compression stroke, etc. Compression stroke and power stroke followed by the last stroke called exhaust stroke. So for this fourth stroke, what we have is in inlet valve opens, exhaust valve opens, inlet valve closes, exhaust valve opens. So this opening and closing will take place. And what happens when the exhaust valve closes well in advance? Okay, there is always the torque loss will happen, which will affect the engine performance. Okay, because of that, you have losses called blow-down loss. That is nothing but engine loss. And again, it is engine is having four-stroke, intake stroke, compression stroke, power stroke, and exhaust stroke. So, and again, the cycle repeats. Okay, the cycle repeats. So when there is a cycle repeat is taking place between intake to the exhaust and exhaust to intake, there is always a loss called pumping loss. Okay, again, all these losses will create 76% overall loss to the engine, which means again remaining 24% is there. And again, as I said, city driving is basically the standby. Mostly the vehicle will be running in standby condition. Okay? When running in standby, you have again 8% loss because the fuel is getting lost. Okay, that's why you can avoid the standby loss when you're going for the electric vehicle concept or even a hybrid vehicle concept. And again, you get 16% in the case of driveline where the transmission things happens. So here in driveline loss is very less, only 30%. And whatever the overall thing you are going to get is 13%. Of course, as I said, the vehicle related thing, the performance of the vehicle, irrespective of engine or electric concept, the aerodynamic version, rolling version, and braking version is also very important tree vertical, which will influence the range of the vehicle. So basically, the mileage you call in the case of engine and the maximum kilometer or the miles it can go per charge in the case of electric or hybrid vehicle. So this vehicle related is also very important. The powertrain related is also very important. Put together, the powertrain plus vehicle related will have the overall influence. This is the example of a Toyota Camry vehicle, which had taken. This is not the concept alone. This is the result. Okay, this is the analysis of this is the report basically, which was done in a research lab, or it's not a research lab, but it's a real-time test condition which was done by a company called Toyota in a vehicle called Toyota Camry, year 2005. This is an example of a urban drive cycle city driving condition. Same one, same Toyota Camry, when it was taken to highway, what happens is, as I said, in highway there will not be any traffic condition. Okay, so here the standby is 0, but again there will be slight increase in the engine loss because you have also the friction loss will happen. Okay, friction, what is called friction? Okay, when the vehicle is running in high speed, there is always a lot of mechanical components which is running inside the engine. So the friction between the moving parts are more, which again creates more engine loss. Obviously, the driveline loss also will be slightly higher. But the overall efficiency is slightly higher in the case of highway driving condition. Still, you get a 6% increase respect to the city driving condition for engine. And again, of course, the aerodynamic rolling will be higher, but the braking will be lesser because in the case of city driving, you have more braking rather than highway. So coming back to the very interesting concept called hybrid, where you have different type of hybrid. Okay, micro, mild, plug-in, and full hybrid. So when I say it's a micro hybrid, it's a start-stop technology. I said it's a start-stop technology where you have belt starter generator, so you can eliminate this 8% standby. So when I say it's mild hybrid, you also have the regenerative braking. So when you have the regenerative braking, what happens is the braking concept. you are bringing that to the city driving condition. Okay, so where you continuously apply the brake, mostly in the city driving condition, and you can, this will act as a mild hybrid also. And the third one, basically the full hybrid. The full hybrid, basically it is having both engine and also the electric motor concept I said. So this will also help you to downsize your engine and also to decouple the engine along with the flywheel. And the last one is the plug-in hybrid electric vehicle, which can also eliminate your engine completely. So which means when I said the PHEV, I said the example of PHEV 40 and PHEV 60, which means in a single charge, you can run the vehicle up to 40 miles and 60 miles. Which means you are not going to use the engine at all, which means you can completely eliminate the engine. Okay, so that's why I'm telling, and the plug-in can completely eliminate the engine entirely itself. Okay, so now I'm going to compare with the motor. So in motor, there is no motor loss, too much motor loss like engine. Okay, you have only the motor losses, which is almost only 10%. You don't have any standby loss. Okay, you don't have any standby loss, so you have 90%. But again, you have some driveline losses are slightly higher. It's a single speed by gearbox, the driveline losses will be more. And again, still you get 76% efficiency. And again, you also need to design the vehicle, because it's not only the powertrain alone playing a vital role to decide the range or the efficiency of your vehicle, but also the three verticals: aerodynamic parameters, rolling parameters, and braking parameters of vehicle is very much important. Okay, so this is very much important, wheel to wheel efficiency. So basically, you call well to tank and then tank to wheel. So you can see one with respect to the electric vehicle, another one with respect to the engine concept. Basically, in engine, you do the as I said, the source of engine is a fuel, which can be either diesel or a petrol. You need to refine the process. Okay. Whereas electricity, you need to generate your electricity. The generation will happen because of electric concept, and the refining will happen because of a fuel concept. So you see again, after generation, you need to transmit the power whatever you generated out of here, the power station. Okay. Similarly, after you do the refining, you need to take the particular oil or particular fuel, whatever you refined, to your wheel. The transmission efficiency is almost 94% in the case of the electric concept, and 98% in the case of the fuel concept. Okay. And again, when it is going to the pump station, again it loses almost 18%. Here you have the grid, basically grid kind of thing. Okay. So you see, still it is higher. As far as fuel is concerned, it is 80%, whereas the grid is concerned, it is 31%. Okay, there are a lot of losses which happens between the transformation from the power from station, power generation to the station to the top grid. You see only 31%. Still, you have a lot of scope to do research how to reduce the losses, but still, the present scenario it is only showing 31%. But you see, this is well ahead. Fuel is well much ahead with respect to the efficiency is concerned. With respect to the station, this is input. Okay, we normally get the fuel from a fuel station, and basically grid where the power is getting transferred to the electric vehicle. And this is the one where this input for generating the combustion for a vehicle. You see, when from pump, when it is transforming to the wheel, it means when it is coming out of the process, we get 13%. Okay, we get 13%. Which means from from uh, from this 80% concept, you are only you got only 16% the efficiency of it. It means your the overall efficiency from well to tank and tank to wheel is only 13% in the case of fuel concept. Basically, the fuel stations, basically what you get out of it is only 30%. When you're going for a grid station, where the efficiency conversion is better 76%. So this is how this the electric vehicle concept is evolving. The percentage efficiency is much more here. But on the other hand, um, people also debate that the electric vehicle is, even though it is not having any pollution, greenhouse gas effect emission, but to produce electricity, you need to go for either a thermal power plant or a hydro power plant or a nuclear power plant. But nowadays, due to safety issue, people are not going for nuclear power plant. They're going with either hydro and thermal, where you need to burn the coal. But again, the availability of water is also a problem. Because of that, the electricity which is produced out of the hydro power plant is also lesser. And again, the geothermal is also lesser. But we have wind energy. So people use most of the electricity which is coming out of the thermal power plant, where they burn the coal. The research says that, or still the debate is going on, that to burn the coal and to get the electricity out of burning the coal, the pollution or the emission which is coming out of uh, the thermal power station is much more higher than what the electricity or than what the automobile is producing with respect to a pollution point of view. Still, the research, still the debate is going on that still, even though I agree that electric vehicle is much more safer with respect to the pollution outside the environment, but where the source of electricity is coming, that is very much important. If you're using wind energy, it's good. If you're using hydro energy, is also good. Even if you're using nuclear energy, is also good. But we are getting electricity which is coming out of the thermal power station, which means you are also going to burn the coal, where again the electricity which is coming out of the thermal power station, the pollution is much more higher than what the pollution what we are going to get out of the engines. It means carbon monoxide, hydrocarbon, nitrogen oxide emissions, which are found to be much more higher in the case of the thermal power station. But the problem is it's in a road where you have a lot of vehicles. Though the pollution is not here, you are indirectly emitting the greenhouse gas effect, and you are spoiling the environment by burning the coal. Still, the research is going on, but still, we can also look for generating electricity with the help of nuclear power plant, and also we can generate more wind energy to go for a higher version of electricity manufacturing. So the plug-in hybrid electric vehicle (PHEV). So as I give an example of 40-60, where you can will also cover the range as well. So this is the graph. X-axis is the distance traveled and Y-axis is the mode. We have two types of mode. One is engine mode, another one is battery mode. Normally, the engine mode is always in off condition when the vehicle is running in city condition, and when the vehicle is running in highway, the engine will be on, and the battery charging will vary with respect to the distance traveled as well. Normally, when the vehicle is running or when the vehicle is getting started, it starts with the electric vehicle concept. Then there will be a transition to the hybrid operation. Normally, you need to have the engine when the vehicle is running in full performance, which means for a highway where you need to get high performance, so you can always use engine. And for covering the electric vehicle range, you need to use the battery, which is the energy source of propulsion during electric vehicle range. And you should ensure that when starting the vehicle, you need to ensure that the battery is completely charged or it is having a charge to cover the required distance. And you should also ensure that the charge sustaining mode is always fine. So you also have the EPA rating, which means Environment Protection Agency rating. So this will determine the emission norms of the vehicle. Okay. So the vehicle is running in different condition, like the highway condition, the real world condition, and also in the constant speed condition. Okay. And again, the vehicle will be running at different temperature and different start-stop conditions and different load. Basically, the load will be different for passenger vehicle and the load will be different for cargo vehicle. Okay, so for all this, you need to have the rating. Okay, basically, the Environmental Protection Agency rating. You need to have the rating. And normally, in the case of normal vehicle, you have the fuel economy rating, where it deals with mileage. So here it normally deals with the range of the vehicle. For a single charge, how much miles or kilometers it can travel. Okay, so again, you need to test with different driving condition. Okay, so when you're driving the vehicle in a city condition and when you're driving the vehicle in a highway condition, you get different mileage for engine. Similarly, you get a different range for electric vehicle concept as well, and different range you have for hybrid. So all these are been defined by a EPA, Environment Protection Agency rating, where you need to maintain so and so fuel economy. Okay, because normally when I say mileage is more or range is more, what is the advantage? Okay, when the mileage is more, for the same mileage you are consuming less fuel, which means you are avoiding the more fuel wastage to the environment, which means you are avoiding the environment, which means you are avoiding emission indirectly or directly, you can say. Similarly, when you are extending the range of your electric vehicle in a single charge, you are also reducing the environmental emission, because to produce electricity you need to have you need to pollute, because especially a thermal power station. Okay, so when your range gets extended, directly you are reducing the amount of electricity to consume for your vehicle, which means it is also directly protecting your environment. So you need to have the EPA rating as specified by a testing agency. In India, we have testing agency called ARAG. They define EPA rating. Similarly, the individual countries, Europe, they have the Europe testing agency. Basically, even in US, they have the US Federal Test Agency. They define EPA Federal Test Procedure for the American driving condition, and they test with respect to different test timing and different speed, different RPM. Similarly, in India, we have Indian driving cycle condition, and in Europe, we have Europe driving cycle condition. So the average speed of the vehicle in India is 90 km per hour. The average speed of vehicle in Europe is 120 km per hour, whereas the average speed of vehicle in the case of US is 140 km per hour. So with respect to different average speed, they test with respect to different timing, and they will find out the emission, what is the CO emission, what is the C emission, what is the NOx emission, what is the fuel economy, and they arrive at the standard where they need to ensure that the rating, whatever has been mentioned, as per their standard, should match the vehicle test. And this vehicle test will also carried out across all sectors of vehicle. The rating of two-wheeler will vary from three-wheeler, and the rating of three-wheeler will vary from four-wheeler. And even in four-wheeler, you have the different capacity of the vehicle with respect to different weight. This will also vary with respect to weight. Okay, and again, you have higher the weight, again, for that you need to have the corresponding value with respect to EPA. All these standards have been well defined by the agency. You need to ensure that all these ratings have been met. So you have the important thermologies with respect to the electric vehicle. So you have state of charge, depth of discharge, capacity, energy, specific energy, and specific power. So what is called state of charge? Okay, people say SOC. What is called a SOC? Okay, it is nothing but the battery capacity, which is expressed as a percentage of maximum capacity. And when I say it's a depth of discharge, nothing but the percentage of battery capacity that has been discharged, and the capacity is nothing but the total ampere hour that are available when the battery is discharged at a specific current. Normally, the C rating they call in the case of capacity, they range from 100% SOC. So energy, okay, the energy, the unit of energy is watt, whatever. Energy you can define with respect to the electric vehicle concept. It is nothing but the total watts hour available when the battery is completely discharged at a specific current. And this is also rated in C rate from 100% of SOC. And how you can define the specific energy? So specific energy is not basically energy by mass. Okay, energy is normally measured in watts hour, and mass is normally measured in kilogram. And the last important terminology is specific power, which means the maximum power that the battery can provide per unit mass. And which this specific power is a function of internal resistance of the battery. Okay, so V is equal to IR, and again, higher the voltage, the current is also higher. Higher the current, the voltage is also higher. See, and the vice versa. You see. So normally, even when I was charging the battery of my mobile phone, okay, so I purchased the charger having two ports, one port having 2.5 volt capacity, another port having 3.5 volts capacity. Normally, I used to charge using 3.5 volt capacity because the flow of current will be higher, which means my charging time will be lesser. I normally use this concept. Okay. Um, this is quite interesting actually. You can also try that, and this will be still much more interesting for you. And same concept is also applied here in the case of electric vehicle concept. Okay. Still, people say gasoline is a much more perfect fuel because the energy density is much more higher for a gasoline and a diesel, whereas it is lesser in the case of the battery what we are using for electric vehicle. So the olden days you use lead acid battery, now we are using lithium ion battery. The weight of lead acid battery is much more higher, whereas the weight of lithium ion that is slightly lesser than that of lead acid battery. It's not slightly, 3 times less. But even though the weight is lesser, the energy density is not up to the mark what we have for a gasoline and a biodiesel or a diesel. But again, there are other alternative what we can look is the LPG, CNG. But again, with respect to the emissions, we cannot go for the diesel or a gasoline where it is more highly pollutant. But LPG and CNG can be a good option. But again, with respect to the safety and other aspect, you need also need to look into the either to go for a electric version or to go for a hybrid version or to go for a conventional version. But Maruti they play a vital role with respect to the natural gas application. You can see in many vehicle which is running in the Delhi market basically. You see the energy equivalency with respect to the gas. Okay, when I'm taking the LPG or CNG, when I'm having 1 gallon of the capacity of gas, you see to go for 135 megajoules of energy. Okay, uh, you normally get 2.5 so 7 kg. Okay, the gas of 2.7 kg. But when you're going for a electric version, battery version, you need to have the weight of battery is equal to 340 kilogram. Okay, to have 54 gallon. Okay, so which means this 340 kg of battery what you're using for a car will produce 54 gallon. Okay, 340 divided by 54 will be almost some six times. Okay, uh, almost gallons, which means when you're using only 2.7 kg with respect to the normal LPG or CNG, you can get 135 megajoules of energy. So which means this is the energy equivalence that we have for the gas and also battery. You can see the comparison. Okay, so now with respect to the anxiety of the range, okay, battery swapping is also there. Where you can also swap the battery, but you need to see that the size and shape of the vehicle what you're having should be available to swap the battery. And nowadays you also have the fast charging. This is the example of a van where the battery swapping is also taking place. Where they removed the old battery and they put the new battery. But only thing is that you need to ensure the size and shape is matching. If you don't have the correct size and shape, then you cannot go for the swapping of the battery. So battery, as you know, the source is lithium. and India is not lithium constant. We are having more abundant lithium in India. It can also be recyclable. And recycling again, when you're doing recycling again, 90% you're recovering it. Okay. And again, you can also use the battery for extending the battery life. You are having the battery management system as well. You're having the better weight and volume. This is very much important. Okay. How much volume or weight reducing, that is very much will contribute. We also have some alternative chemistries for the batteries. This is the Tesla Roadster vehicle having the 125 miles per hour as top speed. The acceleration is 3.7 seconds to reach 0 to 60 kilometers per hour. And the range it goes for a single charge it goes to 44 miles, and the cost is almost much more higher. It almost comes 1,10,000 dollar. Okay, which means 75 rupees per dollar. You can say almost 85 lakh INR. Okay, it is much more higher for Indian market and the economy, as you know. Okay. Coming back to the trends, mega trends which is happening in the automotive industry. So vehicle to grid is very much important. Even from the vehicle, you are also taking the power to the grid, and again, whenever it's required, you are going to get back the power from the grid. Grid to vehicle and vehicle to grid is the very important aspect which is taking place. Autonomous driving is also an important aspect. Connected vehicles, you have cyber security, you have IoT, you have shared mobility. So these are the future mega trends which is happening in automotive industry. You will see the electric bus technology. Okay? So this is the taxonomy of electric vehicle technology, basically for a bus application. This is the example of a Ashok Leyland bus application. So basically, this electric bus technology is having three systems. One is charging infrastructure system, energy storage system, and propulsion system. So when I'm saying propulsion, as I said, hybrid and electric is the one. So we are again hybrid is having parallel hybrid, series hybrid, and combination of both. And the electric version is also having pure electric and range extended electric vehicle. And this, as far as this energy storage is concerned, you have three type of thing. One, you can use either ultra capacitor or a battery or a fuel cell. Of course, the ultra capacitor cost is much more higher, so you go with the battery. Again, battery is also having a lot of types. Like you can go for lead acid battery or lithium ion battery, nickel cadmium, nickel metal hydride. Nowadays, people are also going for lithium ion phosphate, and they also go for the nickel magnesium cobalt, and also they go for a polymer solid state. And nowadays, they are also using for sodium nickel chloride. There are a lot of options out there, but Ashok Leyland they prefer to go with the lithium ion phosphate and nickel metal cobalt. And again, charging is a very important aspect where they charge Ashok Leyland they charge using overhead method where it's like a pantograph kind of thing where you have seen in the electric railway station in some of the railway application. Okay, so you can charge your vehicle with the help of a pantograph, or you can also use some overhead line, or you can also do the charging with respect to the static and the dynamic with the help of induction. And you can also go for a normal plug-in hybrid. Normally go for a plug-in charging as well. Okay, so as I said, this electric vehicle technology is divided into three versions. So the first, you have a lot of good scope even in the bus technology as well. So where you can do research with respect to the power electronics or connected vehicles, and you can also do research with respect to electrochemistry, thermal management. Even I am also working for this thermal management for the e bus, sorry, for the e rickshaw and e auto, and power electronics, material science and metallurgy, and electrical machines, power electronics, control algorithms, and vehicle engineering. Even I am also doing some consulting work for some of the auto application respect to the vehicle and also with respect to management. So this is the electric vehicle bus architecture of a Ashok Leyland vehicle. So it is having the complete architecture from charging to the complete system. So you have three type of charging application. You can use it either for AC charging or DC fast charging. And you see you have also flexibility for any type of charging. This is very much important thing. And you have the auxiliary power unit, or APU, you simply call it auxiliary power unit controller. And you have the lithium ion battery with nickel metal cobalt. Okay, the chemistry is the chemistry, and the capacity of the battery is 650-volt DC. Okay, and you have the inverter which convert DC to AC, and you also have the power electronics, which is part of the control unit. And you see, you are using traction motor with multi-speed gearbox. Basically, the bus application, you need to have where the load is also on the higher side. Okay? Even what you can do is that the bus what had been shown here, even you can also convert this bus into the truck application. Okay? They have the technology, they have the method how they can do it. Because basically in the case of truck application, you need to have higher load, okay, for which you need to have the same multi-speed gearbox. Similarly, in the case of the bus application, also the load is also more because the number of passengers will be more. And again, the load carrying capacity is also on the higher side, and the length is also on the higher side. Wheelbase is also higher. And again, you need to have the better torque, for which you need to have the traction motor with multi-speed gearbox. And apart from that, you also have the power electronics auxiliary device, which includes a HVAC system, steering system, and also e-compressor, electronic compressor, electrical compressor system as well. So it is completely controlled with the help of the vehicle controller, and you also have the body control unit (BCU). So this is the electric bus charging of circular and vehicle. So as I said, you have different method. One is overhead line, where you are charging it with help of the overhead line, the wires which is going, and you are taking the electricity from the nearby location, and you are charging it. And similarly, the pantograph. So it's like similar concept of what you are using for the railway application. Using the same pantograph, you can also charge your bus. You have a plug-in charging, where from the station you can charge your vehicle, and you have the induction charging, where you can charge and vehicle is even in running condition. So here the input power it is coming to the vehicle. The power gets transmitted with the help of the transmitter. So again, when the power and there is always a magnetic field will be induced. As a result of the magnetic field and electromotive force, you are going to get developed. Okay, so and finally you are going to charge it. So this induction charging, even when you can use it for 100 meter or 50 meter, or for 250 meter. So even you can charge it when the vehicle is running in the running condition, or in the slow motion condition as well. You can charge it. This technology is much more developed in some places in USA and also in Europe. Okay, we'll see the overview of electric two-wheeler concepts and applications. Okay, so this electric vehicle concept is again, it's not only with respect to the electric concept, but also the other integration area is very much important. Okay, integration and system integration is very much important. What is called a system? Okay, because you have different system in a vehicle. You have suspension system, brake system, steering system, driveline system, powertrain system, HVAC system, body work system, electrical system, and interior system. All this system is very much important. Okay, and along that you need to integrate your vehicle with respect to safety, weight management, dimensions, ergonomics, energy, the performance, validation, regulation, change management, and also benchmarking. So you need to integrate both your system and also the integration area to get the high performance vehicle. So what are the perception about the electric vehicle? Basically, the two-wheeler concept. Okay. So you have both positive as well as negative concept. What are the positive aspects of a electric vehicle two-wheeler? Basically, it is good for your fuel efficiency and it's good for maintenance, less maintenance, and it's also good for the pricing as well. And again, the problem is the riding range. The model, okay, the aesthetic point of view is somewhat the issue, and the negative aspect is the charging infrastructure, the problem and dimension and size. Okay, how to overcome the negative? Okay, so the riding range. Okay, basically when I say the two-wheeler, people normally they take maximum of 35 kilometers per day. So riding range is not an issue. And nowadays the model and appearance aesthetic feature, they a lot of vehicle they launched, even the other they have launched, Vespa they launched. So you have a lot of thing respect to the model and appearance as well. And again, charging infrastructure, I said charging infrastructure, we're going to cover only 35 kilometers per day. So even you can also charge even single charging is per day doing single charge or even weekend you can. Nowadays all Saturday, Sunday, sometimes Sunday is holiday for most of the employees. So they can charge even during the weekdays or weekends. For them, the charging infrastructure is not a big option or big issue. And now the only thing is that dimension and size is the issue because people always complain that they are not getting the record size and the dimension what they want. But this is because the motor, the location motor location is always near to the wheel and tire. So as a result of that, the configuration is also needs to change. But again, nowadays the dimension size is also uh, meeting the standards and it is not being a problem to the customer. Okay? So it is a old perception with respect to the dimensions. But of course, there is a problem with respect to charging infrastructure, but the vehicle usage is lesser. Uh, you can use this negativity towards your own positivity because the maintenance cost is also going to be lesser. So why we are going for the electric vehicle concept? Basically, when comparing to the electric vehicle concept, is that your the torque what you're going to get out of the electric motor is much more higher. You can see with respect to the initial stage of RPM, you get higher torque. Even when the vehicle is running at higher RPM, still the torque is much more higher than what you're going to get out of the internal combustion engine. Okay? And this electric motor is it can also produce torque at 0 rpm and its torque output remains almost constant. And electric vehicle do not require a multiple speed transmission necessarily. It does not require to have the multi-speed transmission. Instead, we're gonna go for a single speed gearbox. This is the electric vehicle working concept of the other vehicle. Having the battery, it's having the converter DC converter and DC AC converter where you have the inverter in it and you have the bidirectional power electronic motor drive control and you have motor and generator as well. Okay, so when I said the generator is having the regenerative braking concept, so during that time motor will act as a generator and finally we are going to get the power transmitted to the wheel. We have two type of mode. One is regenerative braking mode, and one is boost mode driving. So when the vehicle is running in the regenerative condition, so how the power is going to get? Okay. So from the wheel, you are going to when you're applying the brake, okay, the brake comes to the wheel where the motor acts as a generator because of regenerative braking. That again will drive the motor. Okay, and again the DC to DC converter will happen, and that again you are storing the battery. You are storing that for your battery. Okay, and again in turn, whatever the energy or power that what you're going to store in the battery, in turn you can use it. What you're going to store out of the regenerative braking, even you can use that during your normal driving condition, where you also where the battery will also convert DC where it is also used for converting DC converter, and it will drive the motor. And again, here the motor will be directly acting, and that motor will generate the required torque, and it will drive the wheel. Okay, so in the case of regenerative braking, from wheel to the battery, and in the case of normal mode, uh, the boost mode they call it, driving mode from battery to the wheel. Okay, so regenerative braking is also called as a buck mode, uh, and the non-regenerative braking mode is called as a boost mode. This is basically the two-wheeler concept. Basically, the engine is replaced with electric motor, and the engine management system is replaced with motor controller. Fuel tank is replaced with battery and battery management system. Petrol station is replaced with electric charging station. You have different type of motor. You have different motor controller. You have battery and battery management system, charging station. Which are the thing which is very much important for your two-wheeler application. Basically. The DC motor, you have different type of motor, DC motor, brushless DC motor. You have the stepper motor with full step and off step, AC induction motor, PMSM, permanent magnet synchronous motor, SRM, switch reluctance motor. So these four motors is having different advantages and disadvantages with respect to the efficiency, with respect to the power density, with respect to the reliability, with respect to cost, and with respect to the use of the usage. Okay, so depending upon the requirement and the cost, you need to select the motor type for your application. Okay, so with respect to mounting, okay, so motor mounting is also the challenging one. So you have two type of drive. One is direct drive, and one is hand drive. So where you are also having hub motor directly motor to the wheel. So what happens is it is good because you don't have the noise here, and this is good for weatherproof as well. It's having less transmission loss as well. It's also good for more durability. But the problem is it adds more unsprung mass to the vehicle, or basically the wheel. But to avoid unsprung mass, if you are going for a chain drive instead of a direct drive, where you are using the belt system rather than going for a hub system like a hub motor into the wheel. So here, this will not add unsprung mass, but it results for high maintenance for you, and this will also add overall weight. And because the noise will be also be higher here, and but it's good for heat dissipation, and it is easy to fix, easy to install, and easy for changing the gear. But the maintenance cost is higher. The weight will get more added here. But here, only problem is the unsprung mass is more because of brake. And sometimes this will also cause for the problem with respect to the wear and tear of the tire as well. So you have different block motor controller. So you have different control unit for that. And the next one is the battery and battery management system. So we use different type of battery for a two-wheeler concept. Basically, now we are going for lithium ion, where the weight is almost 3 times lesser than lead acid battery. So this battery and battery management system is very much important with respect to the power density of the vehicle and also the battery. And this battery management system, it normally has five important vertical. First vertical is it should be the auxiliary and application related with respect to the pre-charge, contact control, and also the cooling control. And the next one is the protection. Okay, it should have protection against short circuit. It should have protection against overload. It should have protection against overcharge, and also discharge, and also overheating. And as far as the performance management is concerned, the battery management system should have the temperature, current, voltage, and it should have a power safe mode and also the balancing mode. And the balancing of the charging and discharging and the health condition of the battery is very much important. And this battery management system should display the status. Okay, what and they should also have the interface the communication should be good, and data logging is very much important. The last important thing is the charging station, a two-wheeler. Uh, so you have three type of charging: conductive, inductive, and battery swap. So you can go with either AC conductive charge, or DC conductive charge, or static inductive charge, or dynamic inductive charge, or you can even go for a battery swapping. So you have a lot of advantage with respect to the two wheeler is concerned, because you don't need to worry about the two wheeler, because per day your usage is maximum for 35 kilometer. Basically, if you want to travel the two wheeler from office to home and home to office. And again, this is good for the service activity, and also the power level efficiency is also you can achieve it. And it will vary with respect to AC and DC and conductive and inductive. But what is important is the method of charging, and how the charging method will benefit with respect to the time and also the cost to the customer. This is one example of inductive charging for a car, where you can also go for a static and also dynamic. Same is applicable for two wheeler. Okay, basically now we are dealing with two wheeler. I will show you in the next slide about how we are doing for a two wheeler, or just to understand how we are going for a four wheeler as well. So here you can go for a onboard charger, where you have the static inductive charging, where you have the coil transmitter, and you have the battery for taking it. Similarly, dynamic is nothing but one where when the vehicle is running, maybe for 50 meter or 100 meter, 150 meter, 200 meter, there will be some range where uh, the the charge will take place inside in the vehicle with the help of the EMF force getting induced, as I stated in one of the vehicle bus application. So here, this is example of a two-wheeler application, where you can either go for a battery swapping. So here, when you're going for a battery swapping, what happens is you need to switch the depleted power with fully charged battery. Okay, you need to have the full charge battery, but the only thing is that you need to ensure that the required size and shape of the dimensions of the battery is matching. So what happens? What is the advantage and disadvantage of the battery swapping? So you have less wait time. Less wait time is the advantage. You don't need to worry about the range anxiety, and you are also having flexibility to charge a battery following charging protocols. Okay, but what are the disadvantages when you're going for a battery swapping? The standardized battery interface. Okay, you may not have the standardized battery. Okay, that is one of the disadvantage that you have. Another one is the consumer acceptance, because consumer have to accept it. Okay, uh, and safety perspective is also the problem. So these are all the integration area that people are having scope with respect to the two wheeler. There's again is basically you have different areas to work: suspension, brakes, tires, safety, NVH, regulation, even the center of gravity. Now you have advantage with respect to the normal vehicle. The center of gravity is lesser in the case of electric vehicle than the conventional engine. And these are the affected parameters. It's not only, you also have both the goodness and also the affected the parameters. Even you can do good with all the parameters, or even the parameters can get affected with respect to the integration, how we are going to do with respect to the system. So you have a signal, electric power, and communication. You see, first we will see the communication, how the communication is happening. The communication is happening between the power drive unit and the voltage battery. Okay, it is indicated in green. And again, the power drive unit and the meter. Okay, you have the meter because it shows the speed and the charging thing, whether it is in medium charge or discharge, what's the state of charge condition. And you also have the electric power, where it is indicated in red. You have the electric power connection between the voltage battery and the power drive unit, and the charger to the volt battery, and converter to the battery, and battery to the power drive unit, and the converter to the low voltage battery. You have two type of voltage: one is low and high, and from low voltage battery to sensors and also to the meter, and high voltage battery to the converter. Okay, and you also have the signal between the vehicle sensors and the power drive unit, and power drive unit to the converter. And this is the three important connections: signal connection, electric power connection, and communication connection. These three are very much important. Okay, so this is example of the vehicle where the ether basically. So here the important thing that the scope what we have, the advantages what we have with respect to the conventional two wheeler. So when we are removing the IC engine, when you're going for a normal electric vehicle, the center of gravity gets lowered. Okay, the CG gets shifted. The higher, lesser the CG is always good, and when distribution gets altered, and it calls for a design change. But you need to do design change in suspension, brakes, and tires. Okay, that is always good in the lower gravity, the center of gravity gets on the lower side. But again, even though it is having an advantage, you need to work for other areas where you need to integrate it. Okay, and again, with respect to suspension, it's good for this is the earth vehicle. It's good for a smooth ride. It's good for accurate steering. It is good for responsive handling, and also it supports the weight of the vehicle. And brakes. Okay, these are we have two type of brake. One is disc brake, and another one is drum brake. And normally we can select the types based on vehicle weight, based on the load acting on the wheel during stopping, and also based on the vehicle driver drive behavior. So this is how the disc brake looks. It is having the disc rotor, disc pad, caliper assembly, wheel bearing, and wheel studs. Because of drum, the disc is not there, where it is having the brake shoes. As here you have disc pad, and you also have a plate and adjuster, self-adjuster because of drum brake. And again, there is a problem only with respect to tire, because the hub motor sometimes when it is directly mounted to the one, and again there is always a wheel chunking, or wheel tear will happen. Okay, tires to be designed based on the motor behavior. Whether you're going for a low speed motor or a high torque motor, you need to select the motor accordingly. The tire needs to be designed. Otherwise, the tire chunking issues can come. And again, the tire noise can also come, which will lead to the, the noise. And again, the wheel noise is much more higher. Okay, that you need to avoid. That is how you need to look for the selection of the tire. This is one of the challenging thing, and you need to go for a low rolling resistance coefficient, where you can also go for a better rolling coefficient tires, where it is having good tread blocks, having in the various size for to reduce the tread noise. And you can also go for lesser voids by reducing the space between the block and then the dampness. And you can also go for a shoulder kind of thing like this. Tires with semi-closed shoulders will run quieter. You can also go for quieter, where to go for a shoulder like this. Or you can also go for a channels. This is a channel where the circumferential grooves, when you are providing grooves, what happens, you can also reduce the noise. Instead of going for this type of thing, you see, when you're going for this design and when you're going for this design, you are having the channels which will reduce the which is having the circumferential grooves, which will reduce the noise. And you see the shoulders, which will run quieter. And voids, what you're having, this is the voids, okay? So you need to provide a less space between the block. When you provide a less space, what happen? One more thread if you provide, the noise will be lesser. Okay, you need to increase the size so that the noise gets reduced. And again, the safety is also the concern sometimes, because you have the high voltage, you need to take care. And the NVH, okay, as far as NVH is concerned, you have less noise, because the engine noise is much more higher than the motor noise. You have three type of noise with respect to the two wheeler. You have road noise, motor noise, and wind noise. You cannot avoid road noise, wind noise. It remains same between the two wheeler or a four wheeler or a engine or non-engine. Okay, but engine noise is much more higher for a two wheeler than the motor noise of a two wheeler. only thing is the motor noise is there, but it is lesser than the engine noise. But in electric vehicle, what you can go for good design, where you can also reduce the NVH. The regulation is also very much important with respect to the two-wheeler, where it deals with the different road condition test, like the coast down test, indication test, the gradability test. They will also test with different gradient, different drivability, different city condition, different highway condition, and different climatic condition, and different brake performance. They test with respect to brake, suspension, noise. They do a lot of EMC test, battery test. They do the test with respect to the motor, the functional test. They do construction test. They also do the wiring harness test and the current. So they do a lot of tests with respect to the ARAI standard, and the standard name is CAS 123. And you have the options for a future battery as well, where you have a lot of new technologies like go with magnesium battery, silicon-based battery. You can also go for a sodium sulfur battery, proton battery, graphite dual ion battery. You also have the aluminum ion battery, nickel zinc batteries, potassium ion batteries, salt water batteries, paper, paper polymer batteries. You have a lot of future batteries. So it's a 10 disruptive battery technologies basically. You also have the sodium ion battery. This has future battery for a two-wheeler as well. So this battery grade salts of using sodium, which is 30%, which are cheap and abundant. And this cell can last longer. It is also good for having more charge cycle. And the raw material is almost 1,000 times more common, and it's also safer than lithium. It's also readily available, okay, and it is also easier to recycle, and the energy density is also lesser, and it's also good for a high charging time. So this is a sodium ion battery configuration, where it is having a sodium ion during charging, how it is moving, the flow of how the flow is going to take place, and during discharge how it is taking. Okay, so it moves from anode to cathode during charging, and during discharging it moves from cathode to anode. And this is also a good technology called graphene. Graphene is a future battery technology. It is 5 times much more energy density than lithium ion. Yeah, and it is also more reliable in terms of safety. It's lightweight, quick charging, better heat. The only thing is that the cost is more. Okay? Even though it is abundant in nature, but the cost is more. That's the point we are going for lithium ion. And the energy, the weight is much more lesser. Graphene is a future technology, of course. Uh, uh, but the availability of graphene is also there. But the problem is the technology is expensive. Even though the cost is lesser. Okay, it's eco-friendly, and even the cost is lesser than lithium ion. But uh, but but when you're using this complete configuration, because this is for high capacity and for fast charging, basically it is graphene. Okay, because of that, the overall cost is much more expensive. Even when you're going for a supercapacitor is used for the fast charge and low capacity, and the battery is used for high capacity and low charge, basically the lithium-ion battery kind of thing. But when you're going for a graphene, it is good for high capacity and also for fast charge, and it's also good for a reliability perspective as well. So electric vehicle is playing a vital role in India. Almost 34.68 percentage of the vehicle. The data shows that India is having the huge opportunity or potential for the electric two-wheeler, especially India after Corona stage, after IT, the two-wheeler will play a vital role in India, and followed by China is having a good market with respect to the vehicle. So this is a 18 data for a two-wheeler, which means the total market size of the 62 million vehicle. Uh, this is the concept where you can see there is a trend for India to have a huge demand manufacture the two-wheeler. And India is the largest market respect to two-wheeler. And as you say, 2030, India will have 60 million vehicle. Okay, and out of that 60 million, 72 percentage of them will be electric. There will be also be possibility that the government of India will also put a rule that beyond 2030 or during 2030 all the vehicles will be electric. That is a possibility, and the government is also looking into it. But now they made after 2023 all two-wheel or all electric vehicle of auto and rickshaws will be electric version. So similar to that, there is a possibility that the rules will be made for two-wheeler as well in the year 2030. So you have good advantages for a two-wheeler, basically for the vehicle with electric version. So it is good for a lower fuel capacity, and you have lesser of moving part. You also have the better storage. You also going to reduce 80% dead weight basically, and it's good for urban condition. Having good for quick diagnosis and real-time tracking. It's also good for a fast charging. It's also good for more space, and even the noise level is lesser. Okay, because the motor noise is lesser than the engine noise. It's very much lesser than the it's also proportional to the square of the current. And again, it's having less emission. Okay, you can see 23 gram per kilometer for electric vehicle, and it is 58 gram for a IC engine. The emission is also almost 2.5 times lesser than the engine. It's also good for a quicker acceleration. The torque is also better. It's good for a fast charging, and it's good for nowadays. They also have the safety navigation, and the CG is also lesser. Okay, so when you're going for a two-wheeler, when you're taking an average of 30 kilometers ride per day, you're going to save 1,000 rupees per month for a fuel and 250 rupees per month for a maintenance. So almost 75,000 you're going to save over a period of a year when you're going for an electric vehicle, which means it's similar to a new vehicle. You can buy a new vehicle. Okay, and nowadays you have a lot of purchasing team, finance. A lot of financial teams are there which they go for the financing the individuals to buy the two-wheeler. So you will see the overview of electric vehicle. So this is the electric vehicle of Aether, which is launched recently. It's having Aether is having different version 450X and 450, and we can compare the Aether vehicle with the normal scooter 125cc and 110cc. You see that the maximum torque is also quite better than the scooter what we have, and the mileage is also quite good. The power is also quite
Excuse,
comparable,
excuse
and
me. Hello.
yeah,
Mr.
I'll just complete in 5 minutes.
Yeah,
Just
yeah,
please.
yeah. Yeah, I know, sir.
Uh,
But can you restart your presentation again, sir? Because some disturbance over here. Can you restart it again?
no, it is started already. Started, right?
Yeah, but someone tried to present again, sir. So can you restart it again? Can you restart it again? Yeah, now it's clear, sir.
So coming back to the comparison between the Ether and the normal 125cc and 110cc, the torque is better, speed is better, power is almost equivalent, and weight is also better, and the price is also quite comparable. So when I'm taking the 450X version of Ether, which is also slightly better than Ether 450 model, and this Ether is much more better than 125cc of the engine version. So because
Excuse
it
me,
is having.
sorry for the disturbance, and I we can't visible your screen, sir.
Can you repeat?
We can't visible your screen, sir. Can you restart it again. So don't be mistaken me, sir.
Mohanraj, any problem?
Yeah, someone have tried to present it, sir. So that's why SAR screen like a shown like a pop-up screen. So that's why I just ask him
Yeah,
to.
is this okay? Is this okay?
Yeah, it's now.
It is visible, sir. Yeah, it is visible, sir. Okay.
Okay. So you also have the different version of the Ether, and you can also compare the Ether 450X with Vespa, and they also coming with electric version. So even as far as the Ether Energy is concerned, they manufacture the vehicle in India completely in-house. They have the chassis, motor controller, electronics, battery assembly, completely they manufacture in India. Almost 90%, 99% of the parts are coming in India only, except cells. Yes, cells needs some additional technology, so uh, it is basically imported. So this is the cell of a other vehicle having uh, the 5 GB. It means this is the configuration of the cell. And again, India is also having the big investment with respect to technology and manufacturing. And this is the motor how it is built for the existing capability of a two wheeler. India is also having a good integration and robustness optimization for a two wheeler with respect to electronics point of view. And again, the seat storage frame modularity is much more important. Okay, so suppose let us grab this opportunity together. Electric two wheelers are also evolving, and it is not yet matured, but there is an opportunity for technology-driven component makers, those excelling in product technologies along with the process technologies. Technology addition providing the better margin and IP protection. Let's invest together to realize this opportunity. So thanks for an opportunity. This is the end of part one. So we will see the part two next. So you can email me at p.arjunraj@gmail.com, and my mobile number is 8778983428. You can ask your queries now.
Yeah, yeah. Thank you, sir. Thank you for your wonderful presentation. And some questions are posted in the chat box. And the first question from YB Obilasu. The range of electric vehicle depends on what? Power or torque or battery capacity?
Okay, so it is a combination of all actually. So it is like combination of all. It's not only the power or the torque or the battery capacity, but also the vehicle weight, the vehicle dynamics, the complete architecture is playing a vital role. It is like the mileage of a vehicle, how you normally call in an engine version like the 25 kilometer per liter or 20 kilometer per liter. So normally, when you're saying the mileage of the vehicle, it's not only the engine alone will determine the performance of the mileage of the vehicle. So similarly, the range of the vehicle with respect to electric is not only based on the battery capacity or the torque or the power of the vehicle or the range of the vehicle. So, but the range of the vehicle is also based on the complete architecture of the vehicle. As I said, you also have the aerodynamic structure. You also have the rolling resistance architecture. You also need to have the braking thing. All this will have a cumulative effect to determine the range of the vehicle. Uh, but the battery and battery system or the motor everything will have a cumulative effect. I cannot say I cannot give more importance to one architecture than the other architecture. So complete architecture is very much important to determine the range of the vehicle, similar to how it is determining the mileage of the vehicle in the case of normal engine.
Okay, thank you, sir. And one more question from Mr. Yuvraj. In full hybrid, when battery will work and when engine will work?
Okay, in the case of full hybrid, normally as I said, you can go for when the vehicle is running in starts in the traffic condition, city condition. Okay, when you're running the vehicle in Bangalore condition or Chennai city condition, or in some Mumbai or Delhi application. Okay, where where there is a heavy traffic. Okay, where the vehicle will be moving very short distance with respect to the time. Okay, so what happens is when you're running the vehicle in city condition, you can go for a hybrid version. Sorry, you can go for a electric version. And when you're going for a when the vehicle is running in high speed, I mean, the vehicle is running in a highway. Okay, there we can go for a engine mode. But now there is also in the case of there is a plug-in hybrid electric vehicle, PHV, rather than the full hybrid, where you can also go for a single shot 40 miles or 60 miles as well. But it's always advisable to go for a engine mode when the vehicle is running in highway, where you need to have a higher performance, which is not possible in the case of electric mode. So the answer is in the case of full hybrid, when the vehicle is running in highway or expressway or national highway, you can operate the vehicle in engine mode, and when the vehicle is running in city condition, you can operate that in electric mode.
Thank you, sir. And one more question from Mr. Vishnu Prasad from Kerala. Conventional e-vehicle or designed to new one? Why there is a no add-on model to existing IC engine to convert it as a hybrid vehicle?
Can you repeat, please?
Yeah. A conventional electric vehicle or designed to a new one existing IC
Hello.
engine to convert as a hybrid vehicle.
Actually, there is some signal issue. I cannot. Your voice is breaking. Can you repeat again? Sorry.
Okay, can you hear me, sir?
Yeah, yeah.
Yeah, now I can hear you. Now you can repeat. Yeah.
Okay,
Now
can I
you
repeat
can.
now?
Yeah.
Okay, so the conventional electric vehicle are designed to always a new one. Why there is a new add-on model to the existing IC engine to convert it as a hybrid vehicle? Is that any possible?
Okay. So see, as far as the aesthetics point of view or the improvement point of view between the normal engine vehicle and the normal hybrid vehicle and the normal electric vehicle. Okay. So with respect to hybrid, basically hybrid is basically a combination of the electric and the engine. Okay, so when you say it's a combination of electric and engine, you need to have the space for the storage of engine as well as the storage of the battery system or battery architecture completely. So when I say you need to have the storage, okay, you need to modify the architecture accordingly, the vehicle architecture accordingly. Okay, you need to have some space for the engine, and also you need to have a space for the electric system as well. So when I say you need to have the space, you need to have the design considering the aerodynamic thing and then the aesthetic point of view. Um, People are doing a lot of design modification, and they do a lot of design improvements. It's not that only modification, but they do a lot of design improvement, design validation. They do because it's not. It is like it is easy for a vehicle to be with either an electric or to be with the engine mode. When you're going for a hybrid, it is a combination of both engine as well as electric. Okay, so you need to have the engine either in rear side or in front side. Mostly the engine will be on the front side. So to have the battery, you need to have some space. Either that will increase the center of gravity of the vehicle, or it will also increase the space, the overall length of the vehicle. So considering all this, you need to have some modification, which is a bit challenging, but it's not only the design modification you need to look, but the complete improvement, the overall design improvement is very much important rather than just the design modification alone. But there is some challenges, I agree. We cannot overcome this because the space is also on the higher side for the hybrid vehicle. But since we are looking for a design improvement, not just a modification, the improvement will answer to the difficulty what we are facing.
Yeah, thank you, sir. And the one last question of the session. Uh, we are planning to use lithium-ion batteries in upcoming electric vehicle, which was discovered at earlier period. Why not we go
Yes.
for the advanced battery technology like graphene batteries for the upcoming electric vehicle?
Yeah, we can. This graphene technology is very good thing where the weight is almost 5 times lesser than lithium ion. Okay, the energy density is also much more higher. Okay, it is very good technology. Okay, even the availability of graphene is much more abundant in nature, equal to that of lithium. And again, the cost of graphene is lesser than the lithium. Okay, everything you have the purchase, but the problem is, the only problem is it becomes expensive. Okay, so the raw material cost is lesser, but it becomes expensive when you are integrating the graphene. Okay, when you're integrating the graphene into the battery, means which means you need to lithium is a source, graphene is a source. Okay, lithium is a material or a source of income or a source of the input. Similarly, the graphene is also an input source. So, but when you're integrating into the battery, the technology of integration into the battery using the graphene is much more complex. It's not only the complex, uh, the system cost to manufacture the graphene battery is becomes expensive than the lithium ion battery. It is a very good source and we can use it, but the problem is it becomes much more expensive. Even though the cost of the graphene is lesser than lithium, but when you're manufacturing the battery with the graphene, since it involves a lot of uh, processing technology, that processing technology cost is more. Because of that, the overall battery cost of graphene battery is more than the lithium. So people are more cost effective, and people prefer to have less cost. So that's why people they do not want to go with graphene. They want to go with lithium ion. But it's a good one, and the weight also less. The weight of the vehicle will also go down. Um, but again, the cost people are cost comparative thing, and again, people are not going with graphene. But still, there is a possibility that in future graphene will be a thing, provided the income of the people should also be higher. If the income is on the higher side, people will not worry about the cost, but they worry about the performance. Even you can also increase the range of range of your vehicle with the help of graphene. Because energy density is higher, even the range will be better, and even the maintenance will be better. Even the warranty also. Now almost Nissan Leaf is giving 8 years. Some of the batteries having 3 years, 4 years, 5 years. Still, the battery life will be also much more higher for a graphene than the lithium ion.
Thank you for your well informative answer, sir. And dear participants, due to time lag, we will post your remaining queries to your to Mr. P.Arjunraj through mail, and we will update you soon. Now, I request Professor and Coordinator of this STTP, Dr. P.K. Devan, sir, to brief about the session. Please, sir.
Yeah, thank you, sir. Thank you, participants, for your patience listening, and thank you for Mr. P. Arjun Raj, sir, for spending your valuable time with us. So he has elaborated many things covering from energy loss to advantages of electric vehicles over internal combustion engines. He has explained with the flow charts, line diagrams about the wheel, well-to-wheel efficiency and the working of hybrid vehicle with the plug-in capacity. And he has covered almost all the topics related with his simulation and other things. And tomorrow also we have one more session by Mr. P. Arjun Raj, and he has answered all the questions. The session, I hope the session is very informative. So I request all the participants to join for the afternoon session by 1:55. PM. Thank you.
Thank you, Professor.
Thank you. And tomorrow,
Thank you, Arjun.
tomorrow we'll see.
Uh,
Tomorrow we'll see the part 2, evaluation and simulation. First we have started performance, then evaluation, and then simulation.
yeah, thank you, sir.
Yeah, thank you, sir.